Hello students, in this video we'll discuss 4.11 and 4.12, two exercise problems of fourth chapter. We'll start with 11th one, 4.11, and once it is solved, we will go to 12th one. In 11th one, we have a chamber given, and in the chamber, uniform magnetic field of 6.5 Gauss is maintained. An electron is shot into this field with speed of 4.8 into 10 raised to 6 meter per second, tremendous speed, and it is entering normal to the field, perpendicularly it is entering into the field. The task is explain why the path of electron is circle and also determine the radius of the circular orbit. And to find out this two, we have charge of electron given and mass of electron given. So let us start with understanding the problem. Consider a magnetic field like this. Now, what do you mean by cross? Whenever you are shown cross, you should understand that the magnetic field lines are going inside. So outside the uh, plane of the screen, you have North Pole, and inside you have South Pole. So field lines are going inside the surface of the screen, and for this situation we will consider a charged particle entering perpendicularly. So let us consider a charge q. Say this is charge q, which is entering with velocity v into the field. Let the magnetic field be minus b k cap. So now when it enters, what will happen? So we know that force is qvb, actually qv cross b. So when I consider v to be vi cap and b to be minus bk cap, what do we get? We will get force to be qvb, and what is I cross k? I cross k is minus j, but we already have negative sign, so minus minus plus, and ultimately force will be in j cap direction. So now your velocity is in upward direction, so that means that when the particle enters, it is moving in x direction, but after entering the field, the particle goes in upward direction. So now force will also change. What is the new force now? So again, if I calculate F will now be q vj cap. I'll have to consider, because now the velocity is in upward direction and magnetic field is same, so minus bk cap. And again, if we look at the force, it is qvb. This time I am talking about j cross k. What is j cross k? It is I cap, and with this negative sign I'll have minus I cap. What do you mean by minus I cap? Minus I cap means the particle will go back. Now actually this is not square path as shown here, because force is continuously acting, and so path will be continuously changing, and it will trace circular path of some radius r. So this is the reason why a charged particle, when it enters into magnetic field perpendicularly, the path traced by the particle is circular. And how do we find out the radius or frequency for this phenomena? So we just have one formula, that the centripetal force mv square by r, centripetal force mv square by r is provided by magnetic force qvb, and hence mv by r is qb. This is the formula available for this situation. Now let us see what data we are given. So we are told that the magnetic field intensity B is 6.5 Gauss. Don't forget to convert it into Tesla. 1 Gauss is 10 raised to minus 4 Tesla. So convert it into Tesla before using it. Then we are told that electron is short with speed of 4.8 into 10 raised to 6 meter per second. So V is 4.8 meter per second. Okay. And then what we are asked to find out? We are asked to find out why the path of electron is circular. That is already explained. Determine the radius of the circular orbit. So R is to be calculated. So is it possible to calculate R? Yes. Look at the formula. R is mv by qb. So we have mass of electron given. See, mass of electron is given here. Do we have charge of electron available? Yes, it is 1.6 into 10 raised to minus 19 coulomb. So charge is also given. What about the other quantities? We have speed given. How much is the speed? Speed of electron is 4.8. Sorry, I forgot. It is 4.8 into 10 raised to 6 meter per second. So speed is also available. And lastly, magnetic field. Magnetic field is 6.5, but be careful, it is Gauss. So convert it into Tesla and then use it. So that is how you should be able to find out radius of the circular path. Now in 12th one, we are told that obtain frequency of revolution. The same situation, but now we are asked to find out frequency of revolution of the electron on this semicircular path, and we are asked to check if it depends on the speed of electron. So from previous problem, now we know that mv by r is equal to qb. Okay, and we know that speed is distance upon time, so 2 pi r by t, or else I can say it is 2 pi r f. So if I use 2 in 1, what I have is m into 2 pi r f upon r is equal to qb. Make f subject of formula here. What you will have? This 2r will get cancelled out, and then if you make f subject of formula, you will have 1 by 2 pi qb by m. Very important result. Substitute values and you will be able to calculate frequency, but the result is very important. This shows that cyclotron frequency, actually we are talking about cyclotron. So how fast the charged particle will complete one revolution? It purely depends on the charge of the particle, how much is the magnetic field, and how much is the mass of the particle. And this is the reason why we cannot accelerate very lightweight particle in cyclotron, because if mass is very less, the frequency will be very high, and if frequency is very high, we'll have to design a source which can change its polarity at very high rate, which is very difficult to design. So this is one of the limitations of cyclotron. So for this problem, just substitute the values and you will be able to find out frequency. Thank you.